I'm confused about is that since we have incisors, our teeth, the pointy teeth, and lions and tigers, they eat meat and hunt, and they have incisors. For an evolutionary question, why would we still have incisors if we're not supposed to eat meat?
Okay, because an incisor teeth, lions don't have incisor teeth. The only type of tooth that is inside a human's head is exactly what is the same as the frugivores. The type of teeth that we don't have any teeth for tearing flesh, but we do have teeth for tearing into the skin and ripping through the skin of fruits and things. And then we don't have any teeth at all like a lion's, that's true, or nor even teeth like a dog, which is omnivorous, and cat also, which is omnivorous. A human being is not omnivorous. We have teeth which are molars, and those molars are designed for taking seeds down, and then the incisor teeth that we have are teeth that fit exactly into a frugivore's head, and those are teeth which are teeth for tearing through the skin of various things. All frugivore in somatotyping have teeth like what we have, but we don't really have any canine teeth, you see. We don't have sort of fang-like sort of much. But the primary difference is not that an ape can have quite large fangs, because it can require those fangs to assist to help to break through various leaf and skins of things. But the big difference is that we have in our teeth, we have teeth for grinding down seeds, and because we have evolved to have seeds, because grain is just very new on the earth, and beans are as well. But seeds are always a big factor in all the fruits and everything, and frugivores have molars that will grind down seed. And so the teeth that we have really are teeth, and the incisors that we have are teeth which are very much important in breaking through skins of things, and we didn't really peel things much, and we often ate a bit of the skin and everything, but peeling is sort of a bit more of a recent phenomena. But we did eat a bit of the skin and everything, and we needed those teeth to cut into that. So when we look at our teeth, you can determine just from the teeth alone what type of food the animal ate. If it is herbivorous, it has totally different type of molar system. If it's a herbivorous animal, which we're not herbivorous at all, and we have nothing about ourselves which can manage herbivorousness. We can't even manage the lactucarium, which is always in all the leaf and everything. It causes human beings and causes frugivores to become quite sleepy, and sort of like drugs-like state. But a certain amount of leaf humans can eat, but we're not leaf eaters. We can eat some. But our teeth fit exactly more into a frugivore's head. Certainly, our teeth are nothing like a carnivore's. But then, if you go beyond your teeth into the stomach, a carnivorous animal's pH of its upper stomach, it has a pH of 4, and it has an enormous amount of hydrochloric acid, but the strength of the pH is 4. Frugivores have very little hydrochloric acid, but it has a very, very high strength, and that strength is 1. All frugivore animals and even herbivorous animals have a very high pH, a very low pH acid, and carnivorous animals and omnivorous animals hover around about a pH of 4 as the most strongest sort of as far as the acid of the stomach is concerned, you don't really require much hydrochloric acid to break down flesh because it has no fibre at all. But the more fibre that is in a food, the more that you have to have a very high and strong acid of your stomach.
Oh, so people low on hydrochloric acid, that many people are, they could actually have problems digesting some life foods because of all the fiber in there.
Yes, because they could be not necessarily producing hydrochloric acid because they could really be missing the chloride molecule.
Sure.
If starchaholics, which lots of people are, that starch is always robbing a chloride molecule, so a person cannot have enough hydrogen even sometimes to... But typically the chloride molecule is missing. But then, if it were true that we would be carnivorous animals and then our teeth would be different, our upper stomach would be different, and the acid would be different, and then the liver would definitely produce uricase, which all animals that do eat flesh, their livers produce an enzyme called uricase. Whereas a human's liver and all frugivores' livers only produce around about 8 grains of, in an average human being, it only produces 8 grains of uricase.
8 grains of what?
8 grains of uricase.
Oh, uricase.
For breaking down uric acid. But when you eat a portion of flesh, you're consuming quite a bit of uric acid, and we don't have the ability to be able to break that uric acid down. We only have enough uricase to manage the functioning of the body, but not in our digestive tract. And then if we go beyond the teeth into the intestinal tract further, if we were truly carnivorous, we would have cannulas in our intestinal tract, which a true carnivorous animal does have. These cannulas, which are rib-like element in the structure of the intestinal tract. Plus, our intestinal tract would be extremely short for a very, very rapid transit of that food through itself, because there's no putrefaction that really occurs in a carnivorous animal. It just sort of eats, and it's a very, very rapid transit of that food through itself. But when a frugivore eats a chop, or a steak or an egg, it's going to remain in their intestinal tract for a long time, and that ends up fermenting and creating a gas. The longer the person goes on like this, the more gas they end up with, the more bloat they end up with. We're just not designed at all to have any flesh, And then as we do, of course, we're collapsing the earth.
Yeah, it's so interesting that in a dog and the carnivores, they actually have a higher pH, which is less acid
Correct.
strength than what we do. That's because you said, because I always attributed the idea that you need more hydrochloric acid to digest the flesh. But you're saying, no, you don't, because there's no fiber in the flesh. There's no fiber in the flesh.
Not at all. In the late 70s and early 80s, I did some great research with a fellow in Mexico, and the major question that we had was, what was the hydrochloric acid levels of the stomach, and then what were the very factors that trigger hydrochloric acid. This was all information that we sort of looked into for so many years to discover actually what the element is that actually causes hydrochloric acid to be released.
That's amazing. Dr. Jubb, let's have one final question, because I know you have to go to sleep. It's 3:00 in the morning there, but I want to get to this.